Hi everyone. In this video, I'm going to share some ways in which you can test your serverless applications. Rather than this being like a step-by-step guide on how to do that, it's more of how we tackled it in a real-world project and the pros and cons in our approach. And the project that we're going to talk about in this video is called Stroll. Stroll is a car insurance website where you can purchase your car insurance policy, obviously. It's one that we built from scratch. Stroll is a web application or a serverless application that runs in AWS. The web application is built with React and TypeScript. This makes calls to an AppSync API. AppSync is the managed GraphQL service in AWS, and that makes use of Lambda and DynamoDB data sources. We also use step functions to orchestrate the flow of events for complex processing, like purchasing a policy or renewing a policy, things like that. And another really critical part of the application is our document processing workload, which makes use of S3, SQS, and step functions and Lambda functions. And when Stroll started, really it relied heavily on unit testing, and that's not necessarily a bad thing. Whenever you're starting a project from scratch, you can't really spend time creating the full testing triangle or testing pyramid, like we say. You have to pick what kind of test is going to be the best solution for solving that problem at the time. How are we going to get the best value out of our tests? How are we going to maintain quality but still get features delivered? And the testing pyramid, but I call the testing triangle because this isn't a pyramid, it's a triangle, is ours looked like this. We had loads and loads of unit tests, but very few or no integration tests, and then some end-to-end tests or smoke tests that we had as well. And what we started to see as a team was that as things got more complex and as our AWS footprint expanded, there was a number of critical parts of our application that had no test coverage. And the examples that spring to mind there are the direct service integrations. So those are whenever you connect AppSync to DynamoDB directly. So there's no like Lambda function there doing anything. That is instead mostly configuration. That configuration is managed by CDK and TypeScript. And step functions as well. Again, step functions are really the only output that you get is a big hunk of JSON called the Amazon States language as a .asl file. And really, you can't write unit tests, in a traditional way using Jest for those. But we do have a solution for local testing that I'll chat about in a second, and Tom should have a blog post on. And then event-driven flows, so like our document processing, which events jump through a number of queues. A huge part of that workload only works in AWS because it goes through S3 and SQS and things like that, and you can't write test flows locally because there's no code there again. And the constant problem that we kept seeing, and this was really the straw that broke the camel's back, in my opinion, was that we would have this problem where somebody would make a change to some Lambda code, and they'd maybe have to fetch data from a new table or try to do something in an S3 bucket. And the code was perfect, absolutely nothing wrong with the code. They had plenty of unit tests, but once that then got deployed, we would find that somebody had forgotten to update the permissions in CDK. Because we follow the principle of least privilege, we don't just let our Lambda functions talk to every single DynamoDB table. They only have permissions to read or write or whatever to the specific table that they need to. And like I just said, sometimes they can only read, and then somebody make a change where that Lambda would then have to go and write to the table, and then the permissions wouldn't be there and it would get an error. And we put in place a rule as a team where we would have to deploy and test our code first in AWS. Everybody in the team has their own AWS account. So have to do a deployment and test it out first before merging it. And that was okay, but that's a step that can be easily forgotten. And if you're under pressure or some kind of time constraint, then that's going to be something that don't have time for that. We'll just, push it, merge the PR and hope for the best. And we agreed that we were going to try and write some kind of integration tests. And through the Stroll evolution process, we tried to lay out like what our motivation would be. And our motivation really was that there was a lack of confidence when we deploy to production. We perform a lot of manual checks before we deploy, and sometimes they don't catch everything. This was increasing our lead time and reducing our deployment frequency, and really wanted to have that all the way around. We wanted to decrease our lead time and increase our deployment frequency. And that was our motivation as a team, but then we need to think, well, what is the benefits for the customer? They're paying for us to spend time writing tests rather than delivering features. So what is the benefit to them? Well, the first one, like I said, is that features can go live quicker. That gives them a competitive edge, and it reduces our feedback loop. We might push a small feature or change and be able to get feedback from them and then iterate on it rather than doing a big bang release instead. Critical aspects of the application are tested. This is kind of obvious, but by having those tests there, we can diagnose issues quicker. We can reproduce complicated bugs, rather than trying to figure out the right API call or click through the UI to recreate something. We could instead just drop an event into the right place, and even reuse the same kind of events from production or development. Obviously, clearing out any sensitive data might be in there to help reproduce those things, and obviously just writing a test to reproduce it, and then fixing the code and then rerunning the test, getting into like that test driven development cycle. And then the ultimate aim there is to not have any loss of business. We don't want to have something that gets deployed to production that stops somebody from being able to purchase a policy. Integration testing as well could mean a lot of different things depending on what you're working on. So the definition we came to as a team was that it's one that tests integrations with AWS services. We wanted to check that our code was talking correctly to Dynamo, to S3, to SQS, that it had the right infrastructure and the right permissions to do those things. Any third-party API calls, obviously Stroll makes a lot of different calls to different things to get renewed for getting quotes and stuff like that. All that stuff needed to be mocked out because we can't really control our test environment if we can't mock those calls. And so we started to break down the problem. And really, when you're trying to do something like this, trying to introduce like a new suite of tests to your project, you have to start small. And there was a few critical paths that we knew were causing us issues, and we had to figure out a way to test them. So we looked at what actually triggers an event in our project. So we had objects being uploaded to S3, that then puts an event onto SQS, which triggers a Lambda function. We had DynamoDB streams. That's whenever something's changed in the DynamoDB table. There's a stream of events that's flowing into SNS to Lambda. That's called a fan out pattern. So multiple Lambdas can subscribe to that SNS topic to take action. We had just a simple SQS to Lambda connection where programmatically we would drop an event onto an SQS queue, and that would then cause a Lambda function to do something. And then we had state machines, which are step function state machines, which would make calls to multiple Lambdas. And the pattern that you can see, laying this out like that, is we have an event that flows through a bunch of managed services, and really there's not much to test. There's no we try to keep our business logic out of those things because it's very hard to reason about a workload if you have your business logic spread across multiple things. So as the event flows through, from S3 to SQS to the Lambda function, we don't have necessarily any business logic to test, or other than maybe one or two small bits of configuration. But we still want to test that flow is working correctly. We still want to check that it's all connected properly, it's all deployed, and it has all the permissions that it needs. We have the most control over the Lambda function. That is, TypeScript code. It's easier for us to try and control some kind of test setup in that environment. And we want to be able to put those functions or the state machines into some kind of test mode so that it would be aware that it's run as part of a test and then be able to mock out its calls to third parties. And then we wanted to be able to track test data that's created so that it can be cleaned up afterwards. One of the most critical parts of the Stroll application is how we process policy documents. This part of the application had enough complexity to be able to develop a good pattern for writing our tests so that engineers could build upon it in the future. So this is the first workload that we were going to write an integration test for, and it looks something like this. So we have an object being uploaded to an S3 bucket. In this case, that's a PDF. And that event then gets placed onto an SQS queue, which then triggers a Lambda function. That Lambda function then makes a call to a third-party API. It then updates a DynamoDB table with some of that data, and then moves that file into a destination bucket. And really what we want to assert in this workload is three things. We want to assert that the object no longer exists in the source bucket. We want to assert that the DynamoDB table has been updated with the correct information. And we want to assert that the destination bucket has now got the file that we're expecting it. If we could get this working, would be an incredibly valuable test. It not only asserts that the workload is behaving correctly, it asserts that all the deployed infrastructure is there and everything has the right permissions and configuration to talk to one another. And the part where we needed to make some changes was inside that Lambda function. It makes that call to the third-party API, and it needs to be aware that it's run as part of a test and then mock out that call instead. So the solution we came to was to attach some metadata to the object when it's being uploaded as part of a test. Really, for any kind of those workloads, there needs to be some kind of entry point where we can inject some data to say, right, this is part of a test, treat it slightly differently. As that object is moved to other buckets, we ensure that when we copy the metadata with the file as it's being copied to different places. This gave us this entry point into the workload, like I said, and the next step was then be able to enable our Lambda function to be capable of discovering this metadata and then using that for something. And for this, we use MIDI. If you're not familiar with MIDI, MIDI is a middleware framework that's specifically designed for Lambda functions. It allows you to wrap up your handler code so that you can do some before and after processing. From the documentation, MIDI describes itself as being using an onion-like middleware pattern. And there's two phases. There's the before phase, which is on the left of this onion. As you can see, it's sort of separated by the dashed line that goes down the middle. And then the after phase, which is on the right. The handler is the circle in the middle. That's the code that you've written inside your handler for your Lambda function. And really what it does is allow you to do some things before, and it sort of builds up these layers because you can have multiple middlewares all layered, and then the after phase as well. The before phase happens before the handler is executed, obviously. That means that you have access to the request, but not to the response. The after phase happens after the handler is finished, and that means you have access to both the request and the response. And we were already using MIDI for a number of different things. I think we started using it to set up stuff to do with our logger and maybe some stuff to do with Launch Darkly. Because we already had it there and because we knew that it was really nice to use, it was a great place to sort of work out if that Lambda function is being invoked as part of a test before we actually run our handler. And the logic's really simple. So all we had to do in our before phase is check that is test flag exists in the object metadata. We then want to set a global test context inside the Lambda runtime so that it sort of knows I'm running as part of a test and then can use that to make decisions. And then once it's finished, we wanted to clear that test context up. And that's because whenever you set some kind of global state inside your Lambda runtime, that global state will be accessible by the next time that Lambda function is invoked, as long as that Lambda function stays warm. This is part of the Lambda execution lifecycle, and it's really worth knowing how the different phases of that. But it's a really powerful feature that you can cache some data globally inside that function that it can be used by the next call. It's typically used to cache things like secrets or stuff that's expensive to get, like a database connection. But for us, because that would have been a bad side effect, if the next invocation of that Lambda function was a real request that was then treated like an integration test, that would be bad. So we needed a way to clear it up afterwards. The code for our S3 SQS event handler looks like this. In the before phase, you can see that it simply just gets the object metadata from S3. That code is standard code. It just makes a head request to S3 to get that, and then looks for the correct metadata flag. And if that's true, then set that true in our test context. And then afterwards, whenever your handler is finished, all we do is reset that back to false. So it's really simple. Like MIDI, gives you a lot of functionality, and you can write just small amounts of code like this and build up really nice layers for different things. And the test context itself can be as simple or as complicated as you want it to be. I would say that this part here is over-engineered. It could be just a single Boolean variable. It could be a class, as one of my colleagues has recommended. But obviously, if you're using TypeScript, you get carried away with utility types and things like that. And that's why TypeScript's awesome to use. But to be honest, I think this is the hardest part of the test, of the serverless integration testing problem. I believe that the correct way to test these things is on AWS. Trying to simulate AWS in your developer environment is just making things more complicated. Whenever you have a perfectly good version of that running in AWS, that's not really expensive to run. The hardest part is just making that deployed code aware that it's running as part of a test. AWS don't really give us the tools to do it. They are trying to work on these things, and I would imagine that it'll get better over time. And it's probably a side effect of these more managed services being created and becoming more popular, that testing was never really thought of whenever those services were being developed. And once you have a pattern for determining your test context, then the rest is straightforward enough. Our MIDI middleware led us to a really nice pattern where we could create separate middleware based on what the trigger would be. So based on the screenshot here from IntelliJ, you can see that we have handlers for AppSync, for S3, SNS, SQS, and step functions. All of them are very similar in their structure. They just have different ways of determining whether they're running as part of a test or not. We've seen how the S3 version uses object metadata. For example, SQS and SNS, they use message attributes, which are passed up as part of the event. To include that is test flag. Just a side note on step functions, they're by far the most annoying trigger we had to deal with. We have state machines that invoke multiple Lambda calls as part of their execution, and we needed to make sure that is test flag is passed into each one of those Lambda function invocations. There's no nice way of passing that metadata around inside a step function. They don't have a notion of a global state, which would be something that would be really nice, but it's probably something that would be easily abused by people and sort of breaks the notion of a state machine. The only thing that's globally accessible at the time was the context object. It's just an object that is maintained by the step function service itself. It includes information on like what state you're in and various different bits of metadata about your step function execution. And one of the things that it includes is the execution name. You can name the execution of your step function whenever you go to obviously execute it. And that gave us really an entry point to get some kind of information that wasn't part of the payload of the state machine, but was more global to the state machine itself. So because we tend to execute our state machines from a Lambda function, because we had ways of letting a Lambda function know it was running a part of a test, we could make a really simple choice here and sort of say, if the test context dot is integration test is true, then prefix the name of our step function execution with integration test. And this is obviously a bit of a hack, but a nice side effect is that in our execution history of that state machine, we can pinpoint exactly which ones were ran as part of a test or not. Then whenever we pass our payload, our JSON payload into the Lambda functions that are invoked as part of a task, we then include our payload as its own name field in the JSON, and then we include the execution name. And you can see the $$ notation being used for the execution name. That's just a way of accessing that context object, like I said. And you can, if you Google step function context object, you'll see like what fields are included in that. We then take that, find that execution name in our MIDI middleware for our step function stuff. So it's really simple, again, really simple code. If it starts with integration test, then set our integration test flag to be true for the life cycle of that Lambda function. So that really allowed us to make Lambda functions that are invoked as part of a task aware that they're running as part of a test. Another difficult thing to do when testing step functions is error scenarios. Because we make quite heavy use of the retry and backoff functionality. That then really means that like tests that try to test some kind of failure state can be incredibly slow because it could be waiting for an unknown amount of time. A colleague of mine has written this great blog post on how to test step functions locally. And inside that, he describes how you can use a Docker image called step functions local, which is created by AWS, to take your ASL file from your step function, run that locally, mock out all the calls that it makes, and then assert that it enters any choice statements or things you have. You can check that it's actually entered into those states. So it's brilliant for being able to test things, like essentially writing more like a unit test for a step function rather than writing like an integration test where it's running on AWS. So we're now at a point where we've figured out a way to get some kind of context into our workload. We've made our Lambda function aware that it's running as part of a test, and it's then able to make a decision based on that. And the next part then is how do we mock third-party APIs? And I'm going to just list out a number of options that we considered as part of our work and then share the one that we actually chose. So the first one could be WireMock. I could see a solution where you have WireMock running inside a Docker container and deploy that in AWS using App Runner or something like that. And then inside your Lambda function, if it's run as part of a test, make an API call to the WireMock instance rather than making an API call to the real thing. I think that'll probably work pretty good. It was just for us, that was a lot of infrastructure that we didn't want to have to spend time investing in and deploying, just really for test stuff. So we looked at then options around API gateway. So could we, either spin up our own custom API and like maintain a bunch of code for this, which seemed like a lot of effort. API gateway also has a way of doing built-in mock integrations. So you can say, for this given URL, return this stubbed response. I think that'll be a really good option. But it was something that we sort of learned afterwards, and it has some limitations on how you can control. It's kind of basic, and it's different. Like Wiremock gives you options to be able to sort of say, in this scenario, return this JSON, in this scenario, return that JSON. But the API gateway version doesn't really do that. It's more just for stubbed responses as you're building out. If you have a front end team developing an app and they just want a stubbed response they can work against until you actually get your back end created. DynamoDB is the third option. It's the option that we actually used. Instead of, we created this mock HTTP client that instead of making the actual call to the API, it instead runs a DynamoDB query instead, and we have the partition key of that table is based on the API call that it's trying to make, and then the value that gets returned is just a JSON response, which has been seeded as part of the test run. This gave us, we sort of had the different bits and pieces we needed to actually spin this up, and it gave us the flexibility for controlling what happens as part of our API call without needing to deploy a bunch of additional infrastructure. And obviously and then the other option then is that when we use this in some cases where if you just want to return a hard-coded response and it doesn't really need to be dynamic or that complicated, then you can just return a hard-coded stub instead. And there's pros and cons to each of these choices, but we just picked the best option for our setup at the time, and it's something that we can obviously improve on as things progress. So once we've sort of got all the bits we needed then. So the test context is coming in, the Lambda function's aware, it's now making a mocked call. We have to then assert the three things that we chatted about at the beginning, asserting that something has happened. A typical test in our project would look something like this. Obviously, a lot of stuff has been abstracted away here, but we follow this arrange act assert style where we seed some data, we upload a file to a bucket, and then we want to assert that that has been deleted and has been moved properly. And if we jump into one of those assertions, we're using a library called the AWS testing library. It gives us some really nice add-ons to the expect function in Jest. And in the screenshot, you can see that we're expecting a bucket to have an expected key, which is great for what we were looking to test. Does that object actually exist in the bucket? We also use, it has things for expecting that a DynamoDB table has an item in it. You can expect that a step function state machine is in a given state when it finishes. You can expect that a certain log message has been logged to CloudWatch, and there's a number of other things as well. But it's a really nice little library that allowed us to assert the things we wanted to without having to write a bunch of custom code. So that it has built-in, retry and back off and timeouts and things like that, which is something that will make the test flaky because they have this distributed system. Sometimes things can be warm and execute really quickly. Sometimes Lambda function might take different times to start up, and then your test needs to be able to work in those two different scenarios. So it takes a lot of fine tuning to get it right, but you can get it into a state where by and large it is as reliable as any other integration test that I've seen. The two places we run our tests are on developer machines and on CI. Every developer in our team has their own account, and they're regularly deploying a full version of the application and then running the integration tests against it. When I was working on these tests, the flow that I got into was I was able to write my integration test or make different versions of my integration tests, turn on hot swapping in CDK, and then make changes to the code and run the tests, make changes to the code and run the tests. And because hot swap is continually deploying the code in the background, then I got into a really nice flow where I was able to do some test-driven development of those things, and it sort of helped reduce that feedback loop that can be quite slow sometimes when you're working with serverless stuff. On CI then, we run these tests against the development environment after a deployment has finished. We would really like to run these tests against production, but we're still not quite confident yet on how we clean up the data and the reliability of those things, but that's where we'd like to get to. So yeah, some things that could be better. It'd be great if whenever we created a pull request that we had some way of spinning up a temporary environment to be able to run those tests against before they get merged to development. The way test data is cleaned up is quite complicated. There's some options we have there in making that much better. Potentially setting a TTL on DynamoDB records so that they clean themselves up and then maybe trigger objects to be cleaned up as well from S3. We'd love to run the test against production. And then I'd really like to open source the middleware that we chatted about as well. To summarize then, yeah, the integration test I think was a really valuable change to our project. It definitely helped with the issues that we've lined out. And it can be nicely summed up with three of the four key DORA metrics. So deployment frequency. As our team's confidence increased when performing deployments, that then increased our frequency essentially. It wasn't left to a single person to do. More of the team then were able to do deployments when they were ready. The lead time for change as well. There was less manual testing involved, so it took less time for a commit to make it all the way to production. Our change failure rate, because we weren't getting those permissions errors anymore, and we were testing, for more complicated bugs, the percentage of deployments causing a failure decreased, specifically around those permissions errors, which is what we were trying to really solve with our test in the first place. Serverless testing is a hot topic at the moment. AWS have responded. They've got some great examples. There's a GitHub repo link there that links to a bunch of different things. On the Serverless Land website, which the developer advocates maintain, there's a bunch of stuff there about integration testing as well.